All right, welcome. We're going to calculate limits using continuity. And as a reminder, continuous functions are the ones that you essentially don't need calculus to evaluate the limits with, because you can move the limit inside of the function. You're continuous at a. If the limit of f of x as x goes to a, you just get by plugging in x equals to a. So it's just f of a. And remember, you know a lot of continuous functions, things like x to the r, like x squared, x cubed, or x to the 1/2, a to the x, e to the x, log x on its domain, sine x, cosine x. These are all continuous functions. And an important result is any way you put together continuous functions, addition, multiplication, division, composition, everything stays continuous as long as you avoid division by 0. So don't divide by 0 and it'll stay continuous. All right, the example we're going to do is this really complicated looking gadget down here. Calculate this limit. It looks pretty hideous, but as you see, every part of it is made up of continuous parts. And so it's a combination of continuous things, so it's continuous. The only thing you have to worry about is division by 0. And if you look at this, you have to make sure this is not 0 when you're going to 2. And in fact, it's not, because the biggest sign can be, well, it varies between -1 and 1. So when you add 3 to it, you're never going to get small enough to hit 0. So anyway, it's continuous. That means that we can evaluate this limit really easily just by plugging in. In other words, we change all the x's to 2's. And that's how we get our answer. So the answer will just be 5 times 2 squared plus the log of 1 plus e to the 2 cubed all over 3 plus the sine of the cosine of 2. And there isn't a lot of simplifying you can do here. Let's see, you've got 4 times 5, so that's 20, plus the log of 1 plus e to the 248, all divided by 3, plus the sine of cosine of 2. And that's it. That's the answer. So when your limits are continuous functions, everything is super easy. You can just plug in. All right, that's it. Ciao.